Hi, my name is Chris Paggen. I work for Cisco as a distinguished engineer in the data center group. And what I'm going to be talking about today is how you can use a tool from HashiCorp called Terraform to automate the deployment of application and network infrastructure. And in this particular instance, the network infrastructure is Cisco's ACI. So ACI is an acronym for Application-Centric Infrastructure, and it is Cisco's SDN solution for the data center. So just as a super quick recap, because I understand that not everyone might be familiar with what ACI is. So ACI is essentially a series of Nexus 9000 switches that are configured in leaf and spine architecture as depicted here, and they are controlled by a cluster of controllers. The controllers are called APIC. APIC essentially abstracts the configuration monitoring of configuration and devices through a REST API and, of course, a user interface, which is actually based on that REST API. So what we're going to be doing here is to enable workloads to communicate on the fabric. We will actually use a configuration management tool, which is called Terraform, to communicate with the controllers so that the controllers can then implement our intent or desired configuration end state on the underlying infrastructure. Now in ACI, you have a series of logical constructs, which are tenants, and inside the tenants, you have group of endpoints, which are called endpoint groups. And then you can apply contracts between endpoint groups to allow communication. So by default, no one can talk to anyone unless you explicitly allow communication between endpoint groups. You can also abstract the connection between ACI and a VMware vCenter server, and the vCenter inventory is then modeled as an object in ACI. What that means is I can then apply the vCenter server inventory, if you will, on the endpoint group, and that will cause ACI to program the vCenter server with a port group and a VLAN for virtual machines to join the infrastructure. So that's super high level of ACI. Just all you need to remember, it's a fully programmable data center fabric, highly scalable and intent driven. So you'll see what that means in a few minutes. So this is ACI. The second tool, which is going to come into picture, is Terraform. Now, Terraform is from a company called HashiCorp, which is over here. And HashiCorp makes a series of tools. One of them is in the area of configuration and infrastructure provisioning and management. So as they describe it here, it's a tool for building, changing, and versioning infrastructure safely and efficiently. It is much like Ansible with a twist, a very big twist. Terraform keeps state. In other words, when Terraform pushes a configuration, it knows what it has pushed, and it can compare the configuration on the device with what it has pushed. So with Terraform, you can always ensure that you have an immutable infrastructure. So what that means is if Terraform realizes that there's too much config drift, it will not hesitate to perform a clean slate reset and reprogram the infrastructure to get to your desired level of configuration. So that's quite different from Ansible, which just keeps adding the changes on top of one another. Also, where Terraform is very, very good is at cleaning up. So when you decommission resources, Terraform is very, very good. It will very easily remove what it has provisioned. So that's why it's getting very popular. Also, Terraform has a series of providers, and providers really mean resource providers. So for example, there is a Terraform module for ACI, but there is one for vCenter, there is one for Amazon EC2, there is one for Azure Virtual Machines, there is one for Kubernetes, and so on and so forth. There's dozens and dozens of modules. So I'm going to be exploring what you can do with HashiCorp and ACI in this little session over here. All right, let's get started. So I'm going to log into my fabric over here. So this is the ACI user interface. The user interface uses the REST API behind the scenes. So everything that you see in the user interface is actually queried from the backend API. You can actually inspect all of that, but that's outside the scope of this particular session. So what I'm going to do is jump directly into the tenants section, and you'll see that you have a lot of tenants. Now, a tenant could be a customer, it could be a department inside a customer. They're essentially units of isolation. So if you look at one of these tenants, by default, if you put a workload into one of the tenants, then they cannot talk to other tenants. Resources are completely isolated. It's stronger than a VRF because there is really no visibility between a tenant and another. You can do role-based access control and make sure that only the admin of that tenant sees that, and the admin of that tenant sees this one. And there's no crosstalk or cross visibility, if you will. So right now there is actually a tenant called Yandex demo, which is from me running the demo while beta testing this, if you will. But you'll see that it's going to get destroyed. So if I look inside the tenant, you'll see what I was talking about. You'll see endpoint groups and the contracts that I was talking about. So let me zoom into the tenant now, so you can see what that looks like. So if I go inside the tenant, you'll see that we have endpoint groups under application profile. So this is just a folder. You can, for example, say you have an e-commerce application or a ticketing system, what have you. And then you have these endpoint groups. This could be like web front end, back end, database, Redis, what have you. And between these endpoint groups, you put contracts that essentially decide, how the endpoints that are in here can talk or be contacted. So you have a relation of provider and consumer in the contract, and that decides, what do you provide as a service and what do you consume. And these are essentially filters that are TCP ports. That's all it is. It's like a stateless access list. It's the same thing. And if I go to EPG2, for example, well, this one provides web but doesn't consume anything. So it consumes default, which is a permit any, but it provides web, and the other one consumes web. So you can see that this is giving TCP/80 and this is consuming TCP/80. Now what I can do, like I was explaining, is in the EPG, I can map a domain, and in this case, this is a vCenter server from VMware, vCenter 7, which means that now this EPG will create a port group on a distributed virtual switch on that vCenter, and a VM can then join that endpoint group simply by attaching to the port group, which is corresponding to that EPG in the DVS. That's not done by Terraform, that's done by ACI talking directly to vCenter using the REST API of vCenter. But here's what I'm going to do. I'm going to go to my vCenter server, which is here. I have a small cluster. I have 2 ESXi hosts. There's 2 VMs. You don't pay attention to them. They're not relevant to this demo. And what I have is the code here that I'm going to use to provision my infrastructure. So this is Terraform. Terraform uses a language called HCL. This is the HashiCorp configuration language. Much like in Ansible, you can have separation of concerns. So you can describe the data and the variables completely independent of your code, which is exactly what I'm doing here. So what I have, I'm going to start with simple stuff. I have a series of variables, which I'm defining in this file. You can also get the variables from different sources, from a dynamic inventory and so on and so forth, from a script, but I'm going to keep it simple and instantiate the variables over here. So for example, I have the name of the tenant, which is Yandex demo, the username and key, which I'm going to use to program ACI over here. Where is my ACI fabric? This is HTTPS 168.221, which is where I was browsing before. And then here I have bridge domain 1 subnet and bridge domain 2 subnet. Bridge domain is essentially the Anycast gateway address that is going to be applicable to an endpoint group. So in my case, I'm going to have EPG1 mapped to that BD bridge domain and EPG2 mapped to that bridge domain. Then I specify where is my vCenter object, right? And then what is the name of the object to go to the internet? That's my ACI variable file. Then I have another variables file, which is for vCenter. Now I have my vCenter username and password. I have my vCenter server, SSH user and password. I have a list here of DNS servers. There's only one in the list.
There's different data types, by the way, in Terraform. So here I'm using mostly strings, but you have lists, you have maps, you have booleans. So there's a series of different things. And then what I have next is the cluster, the data center, the data store, and a VM template. Okay, so that's essentially my data structure that I'm going to be using in my code. Well, where is the code? Well, the code is here. There is a piece of code for VMware and a piece of code for ACI. So let's start with the ACI bit. The way you access or address an infrastructure provider in Terraform is by using something called a provider. So Cisco builds a provider for ACI, a provider for NXOS, a provider for DCNM, and there's a provider for multi-site orchestrator, and so on and so forth. And VMware will give you a provider for vCenter, and Amazon will give you a provider for EC2, etc., etc. So here, what I do is I follow the documentation, of course, for the provider, and I provide what it wants in terms of minimum required parameters. So here, the username, private key, certificate name, are we using TLS verification or not? And what is the URL? Well, this is coming from variables in the previous file. Now, you may be thinking, how do I link this code and that file? You don't. You just leave it in the same directory, and Terraform will do the necessary steps to essentially combine the inventory, or I call it inventory because I use Ansible as well, but it will combine the variables and that code together. Then I have something called a data source. A data source is an object which exists already, which has not been created necessarily by Terraform, but I want to get a reference to that object because I'm going to be referring to it. I'm not going to create it or delete it, but I will refer to it. That's called a data source, right? So here I'm saying I will use something from the common tenant. I will use something from this internet connection. But then I have another type of object, which is called a resource. A resource is something that Terraform creates. So in this example, I will create a tenant. This is not something you can invent. So the name of the resource actually is, of course, described in the provider. So if you look at the documentation for the ACI provider, you will find that there's a series of resources. There's plus, 150 plus resources. And one of them is a tenant. And I go and get the name of the tenant, and I can put here a description, right? There's more attributes, and you have to go back to the provider to find out what those are. Then we have VRF, and you can see here that I'm referring to the previously created resources ID. So I have ACI tenant, which is a type of resource, .demo, which is here, .id. This basically says create a VRF in that tenant. Then I have a bridge domain number 1 and a bridge domain number 2. And again, I have references to the tenant and reference to the VRF now. So you can see that this is a hierarchical object model. So it's like a configuration tree. You can think of it as at the top, you have the tenant, then the VRF, and the VRF has optional children called bridge domains. That's exactly what I'm doing here. Then in the bridge domains, I have the subnets. So you can see that the subnet is referring to the ID of the bridge domain. In this case, bridge domain 1. In that case, bridge domain 2. And then I have something pretty cool that I wanted to show you. In case the object that you want to manipulate, imagine there is no resource for it. You go, I want to do something, but there's no resource that Cisco has provided yet for that. Am I stuck? No. We have a generic resource called ACI REST. And that essentially is an interface to the APIC controller's REST API. So you simply give the path, and you can use variable substitution in the URL and in the here text, like so. And it will then post this payload at that URL. So this is a raw interface directly into the REST API. So that's actually very cool because you can then do whatever you want in Terraform, even if there is no object for what you want. Then I have my application profile, my data source for vCenter, and then EPG1, EPG2 down there, and then the domain. So I'm mapping my vCenter to my EPGs over here. And then I'm creating the contracts, right? The web contract, the default contract, and then my filter. See, allow HTTPS, allow ICMP, and which port am I using, and which protocol. That's the code. This is the HCL for ACI. And then I have the same thing on the VMware side. So now you see that the provider is vSphere. So it's slightly different. And what do I have? I also have a bunch of data sources, the vSphere data center, the data store, the DVS, the two networks that ACI is going to push on that DVS, if you remember. So I'm referring to them as data. So I don't create much here. I get references to these objects primarily, right? I have a VM template over here. I have a vSphere cluster, right? And then I have local variables. So these are essentially used during runtime in this specific HCL specification. And what they are is they're, you can think of them as dictionaries, if you know Python or JSON objects. They're very similar. They're called maps in HCL, but they're exactly the same thing, right? They're basically a series of key value pairs over here. It's kind of a list of a key value pair system. So I have a port group map, an IP address map, a gateway map. So you see here, VM1 will have a specific port group, VM2 will have another port group, VM1 will have this IP address, that IP address. I could move this into variables, of course, right? Because I'm doing it here. So I could move this into the variable file and have absolutely no hard-coded values in my code. And then what do? Well, I create, the moment you see resource means create, I create two VMs. I have a loop. The name will be the prefix plus the count of the current iterator. So VM1 will be 1 and then VM2 will be 2. Where do I create it? How many CPUs and how much memory and so on and so forth. Network interface, and you see that I put the network interface in the port group that I want. Right? Then I customize the host, I assign the IP address to it, and I'm pretty much done. What I can do, which I'm not showing here because this is an introduction, so I'm not going to go super deep, but what you can have is something called a local or a remote provisioner. So you can use Ansible either locally on the control machine to run a playbook against the VMs that you created, or you can use a remote provisioner. And that can be just a shell script if you want, or Ansible as well. So if you have Ansible installed in the VM, you can then copy a file using Terraform. You can go get a file, put it in the VM, and then run the Ansible playbook on the files that you copied. So you can use Terraform and Ansible. It's actually very common to do both because Terraform is very good at provisioning infrastructure, and Ansible is very good at configuring applications and things of that nature, which you wouldn't necessarily do with Terraform. All right, so enough talking from me, and I'm going to get started on this. So to give you an example, what I have is a little script here which runs the demo, right? So I go to the VMware directory, I will destroy whatever exists, I go to ACI and I will destroy my tenant, and then I will wait for input, and then we'll do a Terraform plan, and then we'll apply it. All right, so I'm going to get going with this. I'm going to start the script, and then we'll go take a look at what happens on the ACI Fabric and on the VMware side. All right, so I'm in the directory where you have the script over here, and if I run the script, we'll see what happens. So now it's going to go into the VMware folder, and it will destroy whatever it finds. Now it's going to go on ACI, and it will compare the plan that it has with the actual configuration. And it says, okay, I deleted 19 resources. Well, let's go take a look if that's true. So if I go here now, I go in my ACI Fabric. If you remember, we had a tenant called Yandex demo. So if I go here, it's gone. The tenant is completely gone. So it destroyed the tenant. Okay. On vCenter, it didn't do much because there was nothing. But let's go and continue our demo. I will say continue now. And now it's basically telling you I'm going to add 19 things on ACI. Really? Well, let's go see Yandex. So now you see that something is coming up with the name Yandex demo. And it tells you this has been created from an orchestrator. only make changes from the orchestrator. And you see here EPGs, bridge domain, VRFs. Look at the IP addresses for the bridge domains, for example. In BD1, I have 1111. In BD2, 1121. Exactly like my plan, right? So I have my two EPGs over here, and they have the contracts that are defined in the code. They are mapped to my domain. And if I go to EPG1 now, and I look at the operational angle over here, I do not have a VM yet in here. There's nothing yet. Well, that's because Terraform is busy creating the VMs. Now it's creating a virtual machine. So if I go here, you see here that it's spinning up two VMs. So I'm going to give it a couple of minutes. So now the Terraform provider is taking care of powering the VMs. And if you look at the VMs, you'll see that they were placed in the right port group. So VM1 is in port group 1, and VM2 is in port group 2. Right here, right? And again, those port groups, they were pushed by ACI on vCenter, so right there. And they're backed by a specific VLAN. So if I look over here, for example, and you look at the settings, you'll see that there's a dynamic VLAN which was pushed. And ACI takes care of enabling the VLAN on the interface where the VM appears. So it's actually pretty efficient in terms of resource provisioning itself. So now that I have the VMs created and attached and powered up, if I go to ACI and I go to my endpoint group, you see in each endpoint group the VMs coming up. So if I go to EPG2 and I go to operational, you see that I have 112.100, and in this one I have 111.100. And now, of course, what I can do is go to the VM, and in this case, they're very basic VMs, right? But I could have deployed a complete application. And what I'm going to do here is just log into the VM and do a ping, and we'll see if that works. So I'm inside. I'm on the console. So I just log in. And you see that my address is 111.100. So I can ping my default gateway, which is 22BDF8. That's basically the ACI bridge domain. So if I look over here, you will see that 22BDF8. If I go to operational, if I go to policy, L3 out, I have to go here and go to policy and go over here. I'll have the MAC address. So that's it, right? So if I go to the VM and I do IP route, my default gateway is the ACI fabric. And if I go to the 100, well, I can ping the other VM. So you see, without touching a line of command line, I can deploy complete applications and the required network that goes with it. But here's the cool bit. So if I go to ACI now, imagine I made a mistake in my subnet. I can go back here, go to my variables, change it to this. Imagine this becomes 200. You save this, you go into the directory for ACI, and you can interrogate Terraform and say, please compare what I have here with what is on the device. And now it's essentially comparing its current state with ACI, and it will tell us, well, I have to change a few things, 3 to add. And it says, what you want here, which is the new subnet, forces a replacement of the subnet, but the rest is not touched. So it will tell you, everything else it won't touch. Of course, it's going to touch the ACI REST, by the way, because anything which is directly interacting with the REST API, Terraform doesn't know the state. The good thing is the REST API on ACI is idempotent, which means that if I push this 1,000 times, there will be no change unless I really change something. So this is harmless. But Terraform says, the rest I'm not going to touch, just the subnet. And then you can essentially go and say Terraform apply
auto approve. And now watch this. If I look at this subnet, so keep your eye on this field over here, and you'll see that within a few seconds, the subnet is going to change. You see here, that was Terraform. And I can change it again and again and again and again. And if I add stuff myself, or if I remove stuff, it will tell me, well, look, this is deviating from the configuration that you wanted. So that's in a nutshell what Terraform can do with ACI and vCenter in this case. We just scratched the surface. There's a lot more that you can do with Terraform and ACI, of course. And I encourage you to watch other webinars that we've done and white papers and demos. And I hope this was helpful. So thank you very much for watching this.
Great, Chris, hello.
Hello.
How are you?
I am good, and you?
Yeah, okay, thank you for your introduction. So we have several questions and a few minutes. One second, sorry. Could you please tell us about some open source alternatives for Cisco ACI? So, as example, I'm working in rather hyperscaler company, so I want to use several vendors. So, what should I do?
There's two different questions. One is, do we have open source alternatives? And I want to use multiple vendors. So open source alternatives in the area of data center fabrics, there's not much choice, because you're going to have to buy the hardware inevitably, and that kind of limits the choices you have. So there are programs out there where you can buy just the sheet metal, essentially just the switch and the ports, and a very basic slice of software on top of which you can install your own software. Cisco has a program actually which we don't market very aggressively because it's for a very niche market, but we have something called Sonic. So if you want to know more, we can talk about that. So that's essentially Cisco just selling you the hardware without the software, and then you can install something else on top. There is that option. There's other options out there. If you look for white label boxes or white label solutions, you will find something. They are not very popular unless you are a massively scalable data center and you have the engineering know-how to build and maintain a solution like that. So in the enterprise, in the financial sector, in the industry sector, we don't see that kind of solution. But again, if you are a Google-like company, that might work for you. That's
So, am I right? Is it possible to connect Cisco ACI and some open source solution like Sonic? Is it possible?
Well, Sonic is not ACI, right? So Sonic is its own program.
Sure.
Yeah. And yeah, I mean, you could use Sonic and connect it to something like ACI or Juniper or Arista or whatever you want. You will have, as usual, right? If you take systems from multiple vendors, it will be the lowest common denominator that will dictate what works and what doesn't work. So typically, every vendor will give you an RFC compliant implementation of BGP, OSPF, ISIS, VXLAN, and that's going to work. But you will have the basic functionality because it's always the same, right? I mean, a commercial vendor wants to differentiate what they sell you compared to a competitor. So every vendor will try to add a little bit of something on top of the plain RFC version. So that's what you're going to have.
Yeah, fair enough. Okay, so next question. Is any API exist to automate resource creation?
The resource creation in Terraform or on ACI? So yes, I think I understand the question. So if the question is, I would like to automate all of this, the HCL creation and trigger plans, being applied and destroyed. Yes, there is something called Terraform Cloud, which is provided by HashiCorp, which has an API, and you can actually trigger
HCL plans using the API, if that's what you're asking.
Yeah. Thank you. So we should move forward. Please join our Telegram chat and talk with our members. Thank you.
Thank you.